Okay, welcome back to our final session of today. So we were just gonna looking at where's this? Yes, the version with labor, right? So obviously, what I want to do is to develop a similar analysis, but here is the trick. So we're gonna use a trick like this. Now,
paylaşmadınız hocam.
Tamam. Thank you. So we're gonna use a trick like this. So look at this production function. This production function is of constant returns to scale, right? What does it mean? So if I increase both of the inputs by the same amount, production will increase by the same amount, right? So this property will allow me to write GDP per capita in this simple way, or GDP per worker, obviously. So once again, I define that. But now I have KT alpha here, LT1 minus alpha here, okay? And I'm trying to write GDP per worker. So guess what? It satisfies this. So I define this new variable, KT, okay? So this is a new variable that I define as capital per worker, okay? So GDP per worker is again a nice, strictly concave function of capital per worker. All right. So to understand the dynamics of GDP per worker, this is basically what I'm interested in, right? I want to understand the dynamics of capital per worker. Okay. So let's do that. Let's do that. So I have K dot T, which will be the time derivative of what? KT divided by LT, right? By definition. So then it will satisfy this, right? The time derivative of the first one times the second one, the time derivative of the second one times the first one divided by the second one squared, right? This is the quotation rule, right? So what do I know? So let's elaborate this a little bit more. So I have K dot T divided by LT minus, careful here, KT LT times L dot T LT, right? Right? So I'm just taking derivative with respect to time. But guess what? Well, this is itself KT, right? So this one is KT by definition. And this is N, right? Remember, LT grows at a fixed rate. So the only thing I need to do is to understand this. So how do I understand that? Well, I know what it is, right? Because it is S times YT minus delta KT divided by LT, and here now I have NKT. So if I proceed by replacing the terms, I have S times YT LT minus delta KT, right? And minus NKT. So finally, I realize if I replace YT LT, I realize the dynamics of the capital stock per worker is very simply this. Right? So look at this equation. It is almost exactly the same that we studied in the last hour. Right? There is, of course, a key difference. Now, this is capital per worker. Right? In the earlier model, labor was fixed. But now, labor itself is growing. So capital stock will grow as well. Okay? So the steady state, so this equation, of course, is coupled with this definition of GDP per worker. Okay? So I can do the same type of analysis. Does everybody get this? So let me pause for a moment. So if you have any question about the techniques in this slide, let me re-explain, because that's important. You know, trying to understand how I proceed from aggregate to the per worker. Okay, but it's very simple. I'm just taking derivatives with respect to time. So again, I can execute the very same analysis, right? So I have K dot T equals SKT alpha minus M plus delta KT. So if you draw it, you have what? Well, you have your M plus delta KT, and you also have SKT alpha. And the point that they intersect obviously defines the steady state. Then you know that there is a stable dynamic for capital stock per worker. Okay. Now the growth rate, again, now it is the growth rate of capital stock per worker, right? So how do I write that? Well, by definition, it's equal to that. So if I divide this, what do I have? Well, I have S KT1 minus alpha minus M plus delta. So again, you can draw almost the same graph. Here you have minus M plus delta. Okay. Here you have the growth rate. And the figure looks like that. Okay, so this is again K star. And again, it is stable. Right? So the analysis is almost same, right? Because this is very simple model still. But steady state now is a little bit different. Right? So if I want to define the steady state, once again, don't forget the steady state is simply defined in this way. Okay. That's the reason we actually derived this fundamental equation. Okay. So if there really exists a steady state, what is it equal to? Well, again, if I impose this, what do I have? I have sk star to the alpha equals m plus delta k star. So if you solve it, you will have s divided by m plus delta, right? 1 over 1 minus alpha. And again, this is the positive one, right? So once again, you have the steady state here, which is k star greater than 0, and there is a trivial steady state here, and we are not interested in that trivial steady state. Okay, I mean, for some problems, especially in terms of economic history, that could be interesting, but for now, we are trying to understand growth. Okay, so if you know k star, obviously you know y star, right? Because once again, y star is k star to the alpha, right? So you have s m plus delta alpha divided by 1 minus alpha. Okay. Now the analysis of income differences is slightly different. Why? Because if you have two countries in the long run, I and J, let's say, once again, right? Now, you also have some dependence on population growth rates, okay? So if population growth rates in the long run are different, right? So you have Sj, and J delta alpha 1 minus alpha, right? So you have Si divided by Sj divided by Ni plus delta divided by Nj plus delta, and this whole thing raised to the power of alpha 1 minus alpha. Okay? Now, as you see, when we complicate the model slightly, it tells a different story, right? It tells a different story about income differences, and it tells a different story about growth rates, right? Because growth rates are now, so the growth rate of capital stock per worker is once again that. So what does it tell you? Well, if S is large, if saving rate is higher, and if population growth rate or the growth rate of the workforce is smaller, then growth rate of capital stock per worker will be larger. Obviously, right? Because if S is larger, I allocate more resources for capital accumulation. And if N is larger, I need to save more. I need to, we increase the capital stock more to keep the capital per worker same, right? Because population growth rate is faster. Okay. So when we add labor, this type of solo model gets slightly more complex and slightly more realistic. Why more realistic? Well, again, this is not the preferred model, but this is an elementary version. But if you look at long-run income levels, countries with large populations and large, population growth rates are generally poorer. Although this is not a very good explanation for income differences, as we will see in the next weeks. Okay. One final note, and then I'm going to stop. one final note, one final remark. Remember YT, the central object of interest in this version is that, right? So what does it tell you? The growth rate of GDP per worker at any T, so this is instantaneous growth rate, is alpha times, remember our rules about growth rates in continuous time, right? So this is basically that. So at any time, you can actually write the growth rate of GDP per worker, right? And it is equal to that variable. Okay? So you can actually tell me, suppose that you are running a regression. Let me just rewrite this. So I can rewrite this as minus alpha n plus delta plus alpha s kt to the alpha minus 1, right? Does everybody agree? So there is actually a prediction about convergence here, right? Suppose that this is capital stock, or actually, let me do better. Now, from this equation, you can write KT as what? You can write KT as YT to the 1 over alpha, right? So you can write the growth rate in this way. Minus alpha n plus delta plus alpha s. Now replace KT with that. So then you have YT alpha minus 1 divided by alpha. Okay, then if you put YT here and GYT here for many different countries, remember our growth facts, right? That figure was something like that, right, in the data. Remember this from the first week? So these are countries in the world. Okay? So the model now tells you that richer countries must have smaller growth rates, right? The model tells you that. You see? So this part cannot be explained by this model. Okay? So that's important. That's one of the reasons we don't like this model. We don't believe that model is actually a very good theory about long run growth. That's one reason. Okay?
Hocam ilk eşitliği nasıl bulmuştuk acaba?
Şunu mu?
Hı hı.
Şu mu?
Hayır, bir üstteki.
Oh, that's by definition.
Okay.
Remember, YT is equal to KT alpha LT 1 minus alpha. That's our production function, right? So YT divided by LT is KT to the alpha, right? L's cancel out.
Ben o 2y'yi de aynı gördüm de o yüzden kafam karıştı. Teşekkür ederim.
Okay. So I'm going to stop here for your questions and comments. When you think about your questions and comments, let me talk about the next week's plan. So next week, we're going to discuss this labor issue in much detail. We're going to talk about what determines N, right? Now, in the simple model, of course, you see N as fixed, right? Population growth rate, or the growth rate of labor force, is fixed. That's for simplicity. In reality, it is not fixed. So we want to understand the implications of population growth rate that changes in time. Okay? So there are some demographic consequences, right? Populations will get older, life expectancy will get larger, fertility will get smaller. Okay? So for most of us, our grandmothers have 3-4 kids, okay, in Turkey. But our mothers have 1-2, maybe 3 in most cases. And most of you will have only 1 kid. Okay? There are very strong economic reasons behind that. It is, of course, it of course depends on your choices, right? But those choices have some economic determinants. Okay? And we're going to discuss those things because those things are, they have important economic consequences as well. So demography is not just the outcome. It is both the cause and the consequence of some economic stuff. All right? And to understand growth in the long run, we want to visit such demographic elements. So next week, we're going to do that. In the textbook, you can see that there are discussions, there are different types of arguments. So before discussing human capital, we want to understand how labor force changes, what are the reasons behind fertility decline, what are the reasons behind the increases in life expectancy, and what are the consequences. Okay, now I can answer your questions, I can respond to your comments, we have time. I may post some assignments starting next week, so be alert. All right. That's it.
Ne kadar süreli vermeyi planlıyorsunuz?
I don't know. I haven't thought about that yet, but it will be enough time. You know my style. I'm not the deadline guy, so I can leave you a lot of time, so you can work on such assignments.
Thank you.
There will be, of course, a limit, but that limit will be not too strict. Why are you smiling, Hajar?
Hocam aklıma geldi. Ben biraz ders seçiminde sizi çok yordum da bir an onu düşündüm. Ona güldüm birazcık yani istemsizce. Onu diyecektim. Tekrar kusura bakmayın hocam. Birazcık ben galiba tezcanlı bir insanım. Sizi böyle saçma sapan şeylerle uğraştırdım.
Estağfurullah. Hiç
teşekkür ederim.
Saçma sapan değil. Malik, sen bir şey soracak gibisin.
Evet hocam, soracağım da. Ya teknik bir soru soracağım da.
İngilizce sor.
Ya hocam sorsam bugünlük. Çünkü
tamam,
ya
sor
şimdi,
nasıl istiyorsan. Kayıttasın yalnız. Bunlar hep YouTube'a giriyor yani.
Ya Yılmaz Akgöz'ün bir tane kitabı vardı. Büyüme, Sermaye. Tam hatırlamıyorum net ismini ama.
Hatırlamıyorsun. Evet. Sermaye, Bölüşüm, Büyüme. O kitabın adı. Evet.
Şimdi orada da ben bir takip etmeye çalıştım. Bu sefer orada nötr teknolojik gelişmelerden bahsediyordu. Yani Hicks'in, Solov'un bir de Arod'un modellemelerinden. Yani biz bunları daha ileride mi göreceğiz?
Evet. Teknolojiyi konuşmaya başladığımızda 5. hafta mı? Ne zaman? Herod neutral, Higgs neutral ve Solov neutral teknolojik gelişme türleri. Daha çok Herod neutral'a odaklanacağız çünkü Balanced Growth Path'i genelde daha değerli toplamda anlayabildiğimiz teknolojik gelişme türü Herod neutral.
Tamam.
Güzel kitaptır ama. Akyüz'ün kitabı çok iyi bir kitap.
Biraz ağır hocam ama ya.
Biraz ağır, evet. Çünkü klasik Ricardo falan hepsini anlatıyor. Yani Smith, Ricardo, Marx, Keynes. Anyone else? Any questions, comments? You can also share your compliments about, about my teaching style and the content. You are free to do so. I'm just kidding. All right then. I will see you next week on Wednesday afternoon. Again, stay alert for some handouts. I can post some readings. And next week we're gonna continue. Okay.
Teşekkürler hocam.
Bye bye.
İyi
All right.
günler hocam.
Bye bye.
İyi günler.
Have a nice week. Bye bye.